Now question number 56. Salts AB, AB2, AB3, AB2, B3 are sparingly soluble salts and all have same Ksp values. The most soluble salt in water is. Here we have that this Ksp value for the very sparingly soluble salts is very less as compared to 1. We all know that. And if we talk about AB, in water, it forms two types of ion only, A positive and B negative. Let's assume that solubility is S. And in that case, this solubility is equal to root of Ksp. Now the next salt is AB2. The solubility can be calculated because we know that there are 3 ions, 1 A positive ion and the 2 B negative ions would be there. So this Ksp value could be calculated by S into 2S square. So what would be this value? This would be 4S cube. So the solubility that you can find out is equal to Ksp upon 4, and here you have to take the cube root of this. Further, if we talk about the next salt, that is AB3. The solubility in this particular case would be calculated with the help of Ksp value, and this Ksp value is equal to S for this A positive ion, and there is 3 B negative ions are also there. So 3S cube. It means this value would becomes 27 S raised to the power 4. So this would be this value. Further, if we talk about A2, B3, the Ksp value is equal to 2S square into 3S cube. You can find out it. This would be 108 S raised to the power 5. So what would be the value for S? In this particular case, it would be 5th root of Ksp upon 108. And now if you look at all these values, the value of solubility is maximum for the salt A2B3. So the most soluble salt in this case is A2B3, and option 4 is the correct option. Now after this is a turn for question number 57. Which of the following solution has highest pH? We have different solutions here. Basically, we have mixed acid and base, and we have to just find out the excess of the substance to identify whether these are acidic or basic, on the basis of which we will find out the solution with highest pH. Highest pH would always be there for basic solution. Let's find out. Suppose I'm talking about the first case, when 100 ml M/10 H2SO4 is mixed with 100 ml M/10 NaOH. It means in this case, the two substances, one acid and base is mixed, and the N factor of these two are different. So let's find out the normality for the first case. The normality of the resulting solution would be equal to, that is 1/10 into N factor, that is normality, and the volume is 100 ml minus 1/10, N factor is 1, multiply volume here and just divide it by the total volume of the final solution. What would be the total volume? 100 plus 100, that is 200 ml. And if you solve this, you will find out that this value is 0.05 normal, and it leads to the formation of acidic solution because acid is in excess. In the second case, normality N is equal to 1/10 into N factor into volume minus 1/5, and N factor is 1, then multiply volume here and just divide it by the total volume. What's that? That's again 200, and if you find out the final value, you will be surprised to know that this is N value is 0 in this particular case. It means it's a neutral solution, neither excess of acid nor excess of base. Now, in the third case, normality, if you just want to find out, that is equal to again 1/5 molarity into N factor, that's 2 for H2SO4. The volume is 100 ml minus again 1 by 5 into n factor is 1. Just multiply the volume here, that's 100 ml, divided by the total volume. What is that? 200. And if you solve this, you will identify that the value of this n is here 0.1. It means it is also representing more concentration of H plus ion. It means acid is in excess. So acidic solution it is. Now the last case is 1 by 10 n factor volume minus 1 by 2 because the solution is m by 2. N factor for NaOH is again 1. The volume and should be divided by the total volume. What is that? 200. And for this case, this is 0.15. But now in this case, the excess of OH minus ion is there. What does it mean? It means that this solution is basic solution, while rest of these are either acidic or neutral. The second case is of the neutral solution, while first and third is of acidic solution. So highest pH is definitely would be in case of basic solution because rest are either neutral or acidic. So the fourth is the case where the highest pH would be there. That's why I choose it as the correct option. And that is also the correct answer for my question. Now after this, let's take next question. Question number 58. Consider the equilibrium constants of the given reactions. We have different reactions given here. Say this equation is 1, this is 2, and this is 3. The equilibrium constants for the reaction E giving you A will be. In this particular case, we have different equation given here. And on the basis of this, we have to just find out the value of equilibrium constant for the given reaction. So if you look at the given reactions, you will see that this is A, that's getting changed into 2B. For the B is there, getting changed into C plus D. Then 2C plus 2D is equal to E. But what we find out here, we just want to find out E is getting changed into A. So equilibrium in this case is here. And for this particular reaction, you just have to find out the equilibrium constant. This is the fourth reaction. Now, we have to just sum these values. One more thing you should look here, that to obtain A to E, we have to just multiply 2 here. So that this equation becomes 2B is equals to 2C plus 2D. And if you sum all these, you will find out that only A and E would be left in this way. So only A, that's getting changed into E. So the equilibrium constant for this case is K, that is equal to the equilibrium constant for these reactions K1, K2 and K3 are given. For the first equation, this is K1, and whenever you sum the reactions, equilibrium constants are multiplied. So this is K1 into K2 is here, but we have just multiplied 2 here. It would become K2 square and then K3. This is for the reaction A is getting changed into E. But in the question, it is not asked. They are just asking to find out the equilibrium constant for the reaction, that is E is the reactant that gets changed into the product A. It means you have to reverse this equation to obtain this reaction 4. So here the equilibrium constant for this particular case is, say, K dash. That would be equal to 1 upon K1 into K2 square into K3. So this would be the final value of equilibrium constant for the desired reaction. And this value is given in option 3. That's why I'll choose it. This is answer. Now after this, let's take next question. Question number 59. Hydrolysis constant KH will be highest for. We have different salts given here. If you look at the first salt, this is HCOONA. This is sodium formate, then sodium acetate, ammonium chloride and ammonium acetate. So the value of hydrolysis constant KH, that is equal to KW upon KA and KB, the product of K and KB. We should know that the value of KH would be high for that salt which is the salt of weak acid and weak base. Let's identify. If we talk about the first option, this is sodium formate. It is the salt of weak acid and strong base. Further, sodium acetate, again weak acid and strong base is there for the formation of this salt. Ammonium chloride, the salt of weak base and strong acid. So it is not the option. Further, CH3COONH4. This is the salt of a weak acid, acetic acid, and a weak base, that is ammonium hydroxide. And for this value of KH would be the highest value. The salt, that is CH3COONH4. And on that basis, option 4 is the correct option. And now let's take next question. Which one of the following pairs will not act as a buffer? We should know that buffer is prepared by the mixing of a weak acid with the salt of that weak acid. That is called acidic buffer. And if we mix the weak base with the salt of that weak base, then basic buffer would be formed. So H2CO3 is mixed with Na2CO3. H2CO3, weak acid. Na2CO3 is the salt of weak acid. So it is an acidic buffer. So this is the acidic buffer. Further, CH3COOH, weak acid. CH3COOK, this is the salt of weak acid on the strong base. That's why this is also acting as the acidic buffer. Further, we have NaClO4 and HClO4. So if we talk about HClO4, this is a strong acid. And this is the salt of strong acid and strong base. It will not act as a buffer. That's why this is wrong. Further, NH4OH and NH4Cl. NH4OH is a base and NH4Cl is a salt of weak base and strong acid. So NH4OH, weak base, NH4OH and HCl is there to form the salt of NH4Cl. This is the salt of weak base and strong acid. So it is also acting like buffer, but that buffer is basic buffer. So which is not acting as the buffer here? That is given in option 3 and I'll choose it as the correct option. After this, let's take the next question. That's question number 61.